Look at the density of this network. We no longer build isolated software programs. We build sprawling, hyper-connected systems of systems. Yet, despite having more processing power and data than ever before, multi-million-dollar technological integration projects fail at an alarming rate. The root cause usually isn't the technology itself. It is the alignment gap. Notice how the boardroom strategy on one side completely disconnects from the engineering execution on the other. These silos form naturally because the people involved speak incompatible operational languages. The CEO plans in business models, while the developer thinks in microservices. You can hire the brightest engineers on the planet, but if the strategic vision gets lost in translation during execution, the project will collapse under its own weight. Traditional systems engineering frameworks often fall short because they track a product's lifecycle without aligning the competing human interests or translating executive vision into executable code. ISO IEC IEEE 42020-2019 addresses this by establishing a universal standard of performance for the practice of architecture itself. It provides a formal process to bridge the alignment gap, aiming to stop the drain of sunk costs in massive engineering projects. Architecture is often viewed as a static output, a structural diagram of software dependencies, or a map of hardware locations. This standard redefines architecture as the set of governing principles that dictate exactly how a system evolves over its entire lifespan. Look at this diagram. It expands the target away from just software to what it calls an architecture entity. That entity can represent an entire global enterprise, a specific cloud server, or a single microservice. By classifying all these distinct targets as entities, you force the CEO, the data scientist, and the engineer to operate under the same process framework. Placing business models and microservices on the same conceptual playing field is how you dismantle deeply entrenched organizational silos. To manage these entities, the standard relies on 6 core processes. As we see in this diagram, they form a living, cyclical feedback loop rather than a rigid top-down waterfall. It starts at the top. Governance sets the strategic boundaries, and management translates those boundaries into actionable plans and budgets, pushing that data downwards to the execution level. Down in the trenches, conceptualization is where teams explore the problem space and brainstorm initial technical solutions to meet those management plans. Every proposed solution then enters evaluation. Here, ideas are tested against competing stakeholder concerns and non-functional requirements. If a solution fails these tests, it cycles back to conceptualization for immediate refinement. Only the solutions that survive evaluation advance to elaboration, where they are transformed into detailed, unambiguous blueprints for the engineers. Through all of this, enablement provides the continuous tools and infrastructure to keep the engine running, while progress data flows back up to governance for executive oversight. This engine ensures that an idea is stress-tested against reality before a single line of code is written. Testing an idea against reality is difficult when hundreds of stakeholders have competing demands on a single massive system. To handle this, the framework uses qualifiers. Notice how replacing the prefix instantly creates a specific lens, like security architecture, functional architecture, or integration architecture. These qualifiers act as specific analytical lenses. They allow teams to isolate and focus on specific problems without losing sight of the whole entity. This mechanism breaks down an impossibly complex matrix of demands into manageable, distinct areas of focus. The results reshape how projects operate. The acquirer, the buyer, now has objective metrics to evaluate a vendor's proposal instead of relying on guesswork. The provider, or vendor, receives unambiguous requirements up front. This helps prevent scope creep and costly rework halfway through the build. And the end user receives a system built for their actual operational reality, because their concerns were embedded in the architecture from day one. By formalizing these processes, the standard shifts architecture from a technical drawing task to a high-level strategic discipline. In an environment of extreme digital complexity, this standard offers a rigorous operating system to maintain organizational alignment and resilience. The results reshape how projects operate. The acquirer, the buyer, now has objective metrics to evaluate a vendor's proposal instead of relying on guesswork. The provider, or vendor, receives unambiguous requirements up front. This helps prevent scope creep and costly rework halfway through the build. And the end user receives a system built for their actual operational reality because their concerns were embedded in the architecture from day one. By formalizing these processes, the standard shifts architecture from a technical drawing task to a high-level strategic discipline. In an environment of extreme digital complexity, this standard offers a rigorous operating system to maintain organizational alignment and resilience.